Hello, I'm Mrs. J, and welcome to my math class. So today we're going to still be doing the area between the curve, but we're going to look at application problems. And one of them, it states, suppose a company wants to introduce a new machine that will produce at a rate of savings in dollars S prime of x equals 150 minus x squared, where x is the number of years of service. And this is savings in dollar. While producing a rate of annual cost x squared plus 11/4 x. First thing we want to do, how many years is it profitable to use the machine? Well, let's graph it and find out. So to graph it, we're going to plug both of these in there and come on. For the window, when you go to graph it, use -110 and then -5, 155. So you plug both of them into your calculator. $150 minus x squared and x squared plus 11x divided by 4. Window, -110, -5, 155. And hit graph. Now the one I entered first is the one graphing first. We also know that it's a -x squared, so it would be going down, where the other one's a +x squared, so parabola going up. So this one graphed first. This is my savings, and this is my cost. So we know that it is profitable as long as savings is above cost. Over here where the cost is above, you're not making money. It's costing you money. So it's not worth using. So it's good until we hit this intersection right here. So we need to find that value. Second calc, go down to intersect and hit enter. Notice it's on one of the curves and it says first curve, hit enter. Now it went to the other curve, hit enter. Since there's only 2 curves, you can just hit enter through those. Now there's only one place to intersect, but if we had the whole graph, there's actually a place over here. So you need to guess. Now you could put 10, or you could move it, see the cursor moving? You can move it close to the point that you want and then hit enter. So it's 8 and that looks like 86. Yep. But we only need the 8. So it's profitable for 8 years. B asks, what is the net total savings during the first year of use of the machine? Well, the first year, then we would go from 0 to 1. So if we want the first year, it's 0 to 1. The first 2 years, 0 to 2. The first 5 years, 0 to 5. If you only want the 5th year, you would go 4 to 5. So for the first year, and then remember it's the top curve minus the bottom curve. So 150 minus x squared minus c of x, which is x squared plus 11/4 x. I'm going to combine like terms first. So we have 150 minus 2x squared minus 11/4 x. Then we take our integral. 150x minus 2x cubed over 3 minus 11x squared over, we have the 4 times the 2, or you could have just put 8, from 0 to 1. I'm just going to make this an 8. So the 4 was there, 2 times the 4 gave us 8. We want f of 1 minus f of 0. So we plug this into our calculator and we plug in a 1 and we get $147.96 minus 0. So in the first year you'll make $147.96. The next part asks for the net savings over the entire use of the machine. Well, how long is that? Doesn't make sense to have it after 8 years because you're losing money after 8 years. The cost skyrockets. So even if you don't have a replacement, it's not worth using this. So the net savings over the entire use of the machine, you'd only use it for 8 years. So it would be your integral from 0 to 8. So it's f of 8 minus f of 0. To find that, plug in 8. So we already have this in your calculator. Just go to table and put the 8 in. When you put it in, you should get $770.67. So in the 8 years that you have it, $770.67 worth of savings. Okay, there's 2 more formulas. Producer surplus goes from 0 to Q sub 0, P sub 0 minus S of Q. And consumer surplus. Consumer surplus is, oh, there it is, 0 to Q sub 0, the demand minus P sub 0. and the Q and P, that's the equilibrium point. Okay, let's try a problem. It says, suppose the supply of a function is given by S of Q equals 100 plus 3Q to the 3 halves plus Q to the 5 halves. And that the supply and demand are at equilibrium when Q sub 0 equals 9. Find the producer's surplus. So for producer surplus, we're using this formula. We have Q sub 0, but we need P sub 0. Well, to find it, you just plug it in here. And you get 424. So the equilibrium point is 9, 4, 24. So this is our P sub 0 and our Q sub 0. So to find the producer's surplus, which is this one, we go from 0 to 4. Be careful. This is the only time they're not in alphabetical order. X goes before Y, cosine goes before sine, but Q is before P. Quantity. So this is a 9. P sub 0, 424 minus S. I'm going to distribute the negative so that this will be 324 minus 3Q to the 3 halves minus Q to the 5 halves dQ. Now when we take our integral, we'll have 324Q minus, adding 1, 3Q to the 5 halves over 5 halves minus Q to the 7 halves over 7 halves. And we're going from 0 to 9. Now you can reduce this sum by flipping this, or you can plug it in like this. 324Q minus, flipping this would be 6/5 Q to the 5 halves. Flipping this one to 7ths Q to the 7 halves. And we're plugging in 0 and 9. So it's f of 9 minus f of 0. And when you plug in 9, get this. So the producer's surplus is $1,999.50. Oops, sorry about that. Okay, let's try a consumer surplus. Find the consumer surplus. if the demand function for grass seed is given by D of Q equals 200 3Q plus 1 squared, assuming supply and demand are in equilibrium at Q sub 0 equals 3. So then again, we'd have to find P sub 0. That comes out to 2. So our equilibrium point is 3, 2. Now the formula for the consumer surplus goes from 0 to Q sub 0, which is 3. But then it's the demand, 200 over 3Q plus 1 squared minus P sub 0, which in this case was just 2. So I just used this formula. Now to take the integral, we're going to have to move this up. Then we can take it. So we have 200 times 3Q plus 1. Adding 1, we get a negative 1. Divide by the negative 1. Minus 2x. Or Q, because these are Q's. From 0 to 3. Then we want to find f of 3 minus f of 0. And plugging it in, you get 12.67 minus a negative 66.67. And that gives us 54. So you plug this into y equals, go to your table and plug in 3 and 0, and you'll get these two values. It gives us a consumer surplus of 54.